Hello, hearty welcome to you. We are solving examples as part of geometric progressions. Let's try to solve this very interesting problem. If the pth, qth and rth terms of a geometric progression are a, b and c respectively, prove that a to the power of q minus r into b to the power of r minus p into c to the power of p minus q equal to 1. So first let me take what is that geometric progression looks like. I will say the first term is a1, a2, a3 like that, and I will say the common ratio is nothing but equal to R1. Why I am taking R1? Because there is already A and R here. Not to confuse, we are taking first term as A1 and the common ratio is nothing but equal to R1. What is the meaning of that? A2 by A1 is nothing but equal to A3 by A2 is nothing but equal to R1. Okay, right. Now pth term is nothing but equal to A. What is the meaning of that? AP is equal to A. Similarly, A of Q is equal to B. Similarly, A of R is equal to C. Now we know the formula how to find out qth term, rth term and pth term, right? A of P is nothing but equal to, we know that is nothing but equal to A into A is nothing but first term, that's nothing but equal to A1 into R. What is our common ratio here? R1 to the power of an equal to, what is the formula? An equal to A into R to the power of n minus 1. So AP equal to A1 into R1 to the power of P minus 1. This is equal to A. Similarly, I have A1 into R1 to the power of Q minus 1 equal to B. Similarly, I have A1 equal to A1 into R1 to the power of R minus 1 is equal to C. Now, this is what we have got now. What we got? We got that these three equations. Now let's leverage this to prove. What I have to prove? I have to prove a to the power of q minus r into b to the power of r minus p into c to the power of p minus q. But you know the value of a here, so I can directly go ahead and substitute that. I can say it as, instead of a I can write it as a1 into r1 whole to the power of p minus 1. That whole thing I have to multiply with q minus r. Similarly, the next one will be whole to the power of r minus p. What I will have there? a1 into r1 to the power of q minus 1 into r minus p. Similarly, I will have another thing c. C is nothing but equal to a1 into r1 to the power of r minus 1 whole to the power of p minus q. Now this is what I have to prove equal to 1. So what I will do now is I will simplify this, I will expand this. You can see that I can take, you have two terms here, one is a1 and one is r1. First let us write down all a1 terms at one place. I will have a1 to the power of q minus r into a1 to the power of r minus p into a1 to the power of p minus q. This is what I have. So a1s are taken care now. Now we have to worry about r1. So let's write down r1s now. I am putting in another color, r1 to the power of I have p minus 1 into q minus r. I hope you are okay with that because I have p minus 1, q minus r. Similarly, I have r1 to the power of q minus 1 into r minus p. Similarly, I have another thing, that is r1 to the power of r minus 1 into p minus q. Now, you can see that the base is same, so you can add all your exponents. So what it will become now? a1 a to the power of m into a to the power of n is nothing but a to the power of m plus n. So I can write it as q minus r plus r minus p plus p minus q. That will become a to the power of 0, 1. Now let us look into this one. Here also I have a to the power of m into a to the power of n. So what I can do, I can write them all as r1 to the power of, I can add all these, right? So I will say p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q. Now this is nothing but equal to a1 to the power of 0, and this one also you will see that r1 to the power of 0. So anything to the power of 0 is 1, 1 into 1 is 1. Now only the thing is how this is 0, that I will explain you here. What is that? Remember, p minus 1 into q minus r. I will do it here. I will do it here, this part. What is that we are focusing on? This proof, which says p minus 1 into q minus r plus q minus 1 into r minus p plus r minus 1 into p minus q. Now what I will do, first I will take only the first terms. So p into q minus r, q into r minus p, r into p minus q. So I can write like that, right? I can write p into q minus r plus q into r minus p. I can write it as plus r into p minus q. Now what is left out is second term. So I will take minus 1 out and I will say this is nothing but equal to q minus r plus r minus p plus p minus q. Now you can see that this whole thing will become 0. Now if you look into this, this also will become 0. Let me explain that. That's nothing but pq minus pr plus qr minus qp plus rp minus rq. You can see that pq, pq cancels, pr, pr cancels, qr, qr cancels. So everything here will become big 0. So that's how you can prove that this whole thing is nothing but equal to 1. So how we have proven this? We have taken a geometric progression and we said that we know that qth term is b, rth term is c, and pth term is a. So we have substituted in the formula an equal to a into r to the power of n minus 1, where a1 is the first term and common ratio is r1. Now after that we got the values of a, b, c in the formula. What we want is a to the power of q minus r. So what I have to do now is, let me put it in another color so that there is no confusion. This is q minus r and b to the power of r minus p and c to the power of p minus q. Now we know that a, b, c values from here. We know what is a, we know what is b, and we know what is c. Now for that we have to again to the power of q minus r. Now that after simplification you will see that that's nothing but equal to 0. Okay. So that's how we can solve this problem. What we have done is very simple. We have applied just an equal to ar to the power of n minus 1 formula. After that, simple rule of exponents. Powers are exponents and the problem is solved. So See you again in the next session. Thanks for visiting. Bye for now.